Hello, my name is Pooja, and today I'm going to explain my project where I analyzed a credit risk dataset using Power BI. In this project, I performed various tasks such as calculating financial metrics, creating visualizations, and performing segmentation, and much more. I'll walk you through the steps I followed and show how I built different analysis and insights using Power BI and Power BI desktop. So let's start with task 1. Task 1 is for DEX calculations for financial metrics. In task 1, I calculated the average loan amount. Here I show you average loan amount using this DEX formula. First, I created a new measure. I calculated the average loan amount and the average interest rate for each loan grade using DEX functions. First, I created a new measure for the average loan amount using this formula, average credit risk data set and the loan amount. You can see. Then average interest rate using this DEX formula, you can see, and I did the same for the average interest rate. This helped me to understand how the interest rate and loan amount vary by loan grade. Then I created another DEX measure for the default rate. I show you this, you can see. So I created another DEX measure for the default rate by loan grade using calculate and divide functions. This allowed me to see how likely it was for loans in each grade to default. Finally, visualized this matrix with the bar chart and clustered columns, which made it easy to compare the loan grade side by side. So task 1 helped me establish a foundational understanding of loan grades and their associated risks. So my task 2 is a visualization of loan status. In task 2, I worked on visualizing the loan status in relation to employment length and home ownership status. You can see in this graph. This objective was to understand which combinations showed the highest default rates. First, I created a bar chart where I used person employment length, you can see in this graph, and loan status. This chart helped me analyze how different employment lengths correlate with the count of loan defaults. Next, I created a pie chart, you can see in this graph, using person home ownership to display home ownership statuses and the average of loan status. This allowed me to see how ownership types are related to the default rates. Together, these visuals made it clear which employment length and home ownership types had higher default rates, providing key insights into the factor influencing loan performance. Task 3 is a segmentation analysis using loan intent. In task 3, I focused on segmenting borrowers based on their loan intent. To better understand the relationship between loan purpose, income, and loan amounts, I created a clustered column chart where I segmented borrowers by loan intent. For each segment, I calculated the average person income and the average loan amount, which I used in this graph. I created a clustered column chart where I segmented borrowers by loan intent. This allowed me to compare the financial profiles of borrowers based on their loan purpose, such as education, debt consolidation, medical expenses. Additionally, I analyzed the loan amount to income ratio for each intent to identify which loan purpose had the highest ratio. This provided a clear view Yeah, this provided a clear view of how borrowers' income levels compare to their loan amounts, helping identify segments with higher financial risk. And next, I analyze time series analysis using credit history lens. Yeah, in task 4, time series analysis using credit history lens. In task 4, I conducted a time series analysis using the CB person credit history length columns to observe changes in the loan default rate over time. I used a line chart to visualize how the default rate has fluctuated based on the length of credit history, which was treated as a time dimension. I also added a slicer that uh, allows me added a that allows me to adjust the view period dynamically like this. Yeah, I can select the value I want to see. Let's make it select all. This helping identify trends in default rate for borrowers with different credit history lengths. So let's move on towards task 5. Task 5 is predictive insights and what if analysis. So in task 5, I use the what if parameter to simulate different interest rate scenarios and analyze how changes in interest rate could potentially affect default rates. I created a what if parameter that allowed me to adjust interest rate within a specified rate range. Then I added a DAX measure to calculate the adjusted interest rate. Wait, I'll show you this. You can see these formulas. I created a what if parameter that allowed me to adjust interest rate within a specified range. Then I created added a DAX measure to calculate this adjusted interest rate using a line chart. I plotted the adjusted interest rate on the y axis and the interest rate adjustment on the x-axis, which enabled me to observe how fluctuations in interest rates impact the default rates. This scenario testing provides predictive insights by helping visualize potential risk associated with interest rate changes. Next is task 6 is about geographic data exploration. You can see in task 6, I added a custom column for geographic data because I don't have any geographic data in this data set, simulating regions such as California, Texas, Florida. I created a map visualization where each region was represented, allowing me to easily spot which area had higher loan volumes and defaults. This gave me insights into regional patterns, helping in identify areas with higher financial risk. So let's move on task 7 now. Task 7 is about advanced DEX for risk assessment. In task 7, I wrote a DEX formula to calculate the risk score for each loan. If I see you, I'll show you the formula for risk score. Yeah, you can see now this. So I wrote this DEX formula to calculate the risk score for each loan based on factors like loan amount, percent of income, historical default, and employment length. The formulas combine these elements to generate a risk score, which helps in assessing the probability of default for each loan. I display the risk score using a bar chart, making it easy to compare loans and their risk levels. So, task 8 is about security features for sensitive data. In task 8 I am implemented row level security. Wait, I'll show you. I go to the modeling tab, click on view as, and click on this region based access and click on OK. And you can see data based upon this security parameter only. You can see data related to taxes only. Wait, stop viewing it. I implemented row level security to ensure that sensitive data is protected. I created roles in Power BI that limits data access based on user reasons. This means that users can only view the data relevant to their specific regions. So task 9 is about dashboard creation and publication. In task 9, I published this report to Power BI service and design a dashboard that brings together all the visualization and analysis from previous tasks. This made the dashboard accessible online where stakeholders can interact with the reports directly. The published version maintains all the interactivity and ensures that everyone has access to the most up-to-date data. You can see my workspace and you can see. So to wrap up, this project helped in analyzing credit risk data effectively using Power BI, from calculating key financial metrics to visualizing loan status, segmenting borrowers, and performing time series analysis. Each task contributed to understanding the factors influencing loan defaults, implementing security features, and creating an interactive dashboard were crucial to ensuring data privacy and usability for stakeholders. Each task contributed to understanding the factors influencing loan defaults, implementing security features, and creating an interactive dashboard were crucial to ensuring data privacy and usability for stakeholders. So, I hope this walkthrough